thank you for being here and joining us at New Zealand House. It is, as we promised, the view, right? I hope you've had the chance to take photos and selfies and all that stuff. So, and this is really a good opportunity because after July, this whole place will be closed down and they'll be doing renovations for like 5 years. So you guys, this is great. I'm so glad that you're here. Right, my name is Cindy Posimani. This is the formal part. I'm the head of global marketing and export for Howick. And my job today is to MC the event. And to tell you that in case of an emergency, run down the staircase. Oh, actually, no. Go down the staircase quietly and calmly. There's one flight of stairs that take you to the ladies, and the next flight will take you to the gents, and some of you have already found that. Sorry, the cloakroom is open for you to hang all your coats and put all your luggage in. We appreciate that you just come straight off the train, plane, or car. There is something else. Yes, I forgot to tell you this. You're not supposed to take glass out to the balcony. So there are some cups there. So when we're doing the mingling and the drinks and everything else, if you want to go out there, just tip your drink into a cup for you to, So, all right. I think that's the formal part. And then part of my job is to tell you about us. Who knows about Howick and who doesn't? Don't you dare not put up your hand. If you don't know about Howick, you certainly will be, you know about it by the time I'm done with you. And there will be a pop quiz later, so pay attention. Here we go. Howick specializes in the manufacture of precision light steel roll forming technology. For over 40 years, we've committed to innovation in light steel framing with a focus on precision manufacturing, uncompromising quality, and exemplary customer service. And we believe this defines what we call the Howick way. This is straight off our website, by the way. If you don't know this, you don't know us. And Dave Cooper, and whom we sponsor, rattle this on effortlessly every week, right? As a manufacturer, most of our products are exported overseas from little old New Zealand, in case you don't know. That's where we're from. And the majority of our products go into the construction sector in the UK, the US, Europe, Canada, Ireland, and the EU, which is Europe, right? Okay. Howick has enjoyed consistent growth since day one, but we have seen demand balloon in the last 5 years or so as the uptake of modern construction methods has grown. We continue to advocate for more efficient, sustainable ways of building, and this event is part of that journey. All right. That's my part, I think. Oh, by the way, just so you know, we have a diverse group of guests from the industry. It's really interesting. It's a good mix. If you get a chance to meet everyone, do, because we have Howick customers, we have steel frame manufacturers, contractors, interior fit-out companies, architects, engineers, education groups, industry organizations, software companies, and developers. So that is the list that we've got for you, in case you're wondering who is attending this event, because I got asked that question. All right, on that note, please welcome Mr. Nick Corbray, who is our CEO of Howick.
I'd just like to welcome you all here, because I know everyone's travelled, which is great. We were a bit worried we weren't going to have anyone here, but it's a great turnout. So today, really what we're trying to do is a bit of a thought-provoking and think about what's going on in the industry and what's happening. So the global construction industry is about an $11 trillion industry, yet there's only about 1% innovation and growth of new products compared to things like automotive, where you're sort of into the double digits. So that's what we're trying to sort of get people to think about today, is what's going on, what can we do? So we've got some great presenters from different walks of life and doing different things. And then just, it's a great venue, and it was a great opportunity to get people together. And since we haven't travelled for the last 2 years, we've been stuck at the bottom end of the world in New Zealand. It's great to be able to see people and see what's happening again. So just as I say, I'd like to welcome you and enjoy the day, enjoy some drinks after we've finished. And each of the presentations are quite short and sharp. So if you've got any questions, there's brief questions and answers for each presenter. And then at the end, feel free to catch up with people and we'll try and introduce everybody to everybody who needs to talk. So, welcome.
Dave Cooper is co-founder and host of Dave Cooper Live. If you haven't met him, you really should. He has over 20 years experience in the construction industry and shares information he gains from the AEC industry experts on his weekly online video series. Dave and his family are currently traveling across the United States. I think that's no longer applicable because they've sold their motorhome, but they frequently stop and showcase behind-the-scenes stories of those using modern methods of construction to build it better. Dave can often be found moderating panel discussions or acting as master of ceremonies. It's probably like, God, she's doing a crappy job, at events like this, like the International Wood-Based Conference, Building Systems Council Summit, and the International Builders Show hosted by the National Association of Home Builders, one of the largest trade associations in the United States. Dave started out as a combat trauma medical specialist in the US Army, serving multiple tours in Southeast Asia. He was also a rescue worker at the World Trade Center immediately following the 9/11 attacks. So he's a hero too. A father of three, Dave's true passion is coaching youth hockey and helping others succeed. Please welcome Dave Cooper.
Well, thank you for that, Cindy. And I think you did an amazing job. All right. So when does my 15 minutes start? Because that's like my opening of pretty much every show, about 15 minutes. But I do want everybody to recognize, since I've been here, we have met folks from the Czech Republic, Poland, Boston, Massachusetts, right? And I also believe Lisbon. So this is a global audience, and this is something that we do on our show on a regular basis. And I'm assuming I'm using this mic, not this mic, right? Perfect. So we're going to have a fast-paced presentation today. I have never done anything in 15 minutes in my entire life, especially on our show. So we're going to just run through. I'm going to try and give you so much knowledge of what's happening around the world in 15 minutes, and then we can go from there. I'm going to be around all afternoon and all night. But I also want to thank Howick for what they're doing. It is so important that as an industry, we start collaborating and talking with each other. There's a long way to go. We have a long way to grow. We are tired of being in last place when it comes to innovation. Howick's making that change, and some of the people that we're talking about during our presentation, hopefully will show you that. We'll show you that as well. All right, so Cindy gave you a little bit of behind the scenes on what we do. And basically, to sum it up, our show is live, it's interactive. We showcase the people, the products, and the processes that are building it better. And as Cindy said, we have been doing this on our live show. And right now, just our YouTube channel a lot. We're very niche. We are not a million follower YouTuber, but we're averaging about 300,000 minutes watched. That's 5,000 shows, 1 hour shows every month that's being watched. The education's starting to work, and bringing the innovation out to all of you is making it happen. And I have to say thank you to all of you. And some of you in the audience, we had a chance to visit their site. Without you, we can't do what we do. If we all work together, we can all grow together, and we can all prosper together. We can build better, build more sustainable homes, and really get the ball rolling. So let's get into it here. So who is Dave Cooper Live? Like we said, we talk about the complexity of this fragmented industry that we are in. We have a global brand issue. How do we change that? What are we going to do to change it? How are we going to do it together? How are we going to build it better? And that's what we're going to talk about. And some of the things that we talk about on our show, let me go through here, is the Build It Better show. Now, what's fun about the Build It Better show? We have been traveling in that motorhome for 2 years around the United States. This is our second trip to Europe. We got 2 more trips coming up in July and in August. And exactly like Cindy said, we travel around and we showcase people that are building it better. We live stream from manufacturing facilities, from job sites. This week on high-rise buildings, running up and down scaffolding. It's a lot of fun bringing all this knowledge to all of you out there. I got a lot of notes because I have, like I said, guts to go through and be very particular and very exact about what we're talking to, because what are the problems we're all trying to solve? Productivity, reduce waste, cost predictability, client satisfaction and safety, the climate agenda. These are all things that we talk about on our show day after day, year after year. That's 4 days a week we do this right now. 4 days a week we're interviewing people from around the world to discuss these very topics. And I will tell you this, the good news is you start checking the box off on one of these topics, it automatically starts flowing to the other topics. You're not doing one without the other. So achieving the climate agenda and where you want to go is very achievable, and you just have to start somewhere. And that's the best part about this. You add in the pandemic, right? What happens with the pandemic? We're going to add health and safety into all the other issues that we're now dealing with as a company, as a general contractor, as a manufacturer. We got work from home, and we're already struggling with the labor force. So how are we going to create a culture of sustainability and safety? How are we going to extend the lifespan of our current existing workforce? How are we going to bring in the new entrants, the young people, the people with the digital knowledge? How are we going to share that knowledge from the older folks that are leaving our industry in record numbers and early? Those are the questions that we need to answer, because it's not changing anytime soon for any of us. So some of the ways that it's currently happening. If you look on the left, this is AutoVol. That is a 400,000 square foot, fully automated manufacturing facility, $110 million investment, and that attracts young people. That's high tech, that's automation, that's robots, that's cool, but that's unachievable for 99.9% of the rest of us, right? We look on the right here, this is Laos Trust, Simple Wood Trust Company. Know what they've done? They have partnered with the justice system to rehabilitate and train incarcerated people. Think about that. They live near a prison. So their workforce that they're struggling to get, they're working with the incarcerated, justice-challenged individuals and bringing them in to what they do. How about just education in general? These are some of the companies that are doing it. You got CADCO, HBI, Home Builders Institute, Uncommon Construction, and On3. Uncommon Construction, which was on the last slide, they take young people, they put them on a job site, they build a house right next to a trade-skilled master carpenter, plumber, MEP contractor. They learn the trade. And these are kids from high school and inner city. But guess what happens here? When they sell that project, those kids get money put towards their education. They not only learn a trade, but they are rewarded with the profits from the build, which is amazing. On3, Paul Cardis. This is probably the greatest technology that's come out for our generation when it comes to training. So you want to look them up. On3 is using AI. That hard hat has artificial intelligence in it, but it also has something similar to a Google Lens. It's not the Google Lens, but you can say, hey, On3, show me how to pour a slab, or hey, On3, show me how to run this through a Halleck machine. It'll actually come up video, they can watch it, but it can also catch them if they're doing something wrong. It's not just in the hard helmet, it's also on the phone. I highly recommend that if you're looking to train your staff, you want to take a look at this. How do we get to all of this in the future of your business, right? The incremental automation of your manufacturing facility. Or do you not? How many people in here have heard of Ken Semler, Impressa Modular? Anybody? Christoph back there has heard of Ken. The interesting thing about Ken Semler and what he has done is he got frustrated. He builds modular volumetric in all 50 states. All 50 states. And he could not get his product, supply chain, labor issues, all the things that were happening. So he decided to create his own manufacturing facility. The amazing thing about his manufacturing facility, there's no automation. He is building using the best practices that he has learned from working with factories all across the country and using lean manufacturing practices with his process. It's all in the process. You hear Jerry McCarthy say it all the time, right? The profit is in the process. He's building houses faster than the fully automated robotic manufacturing facility. So there's hope, right? There's hope we can get out. Go over here to Integra. How many people know Integra? Probably from Ireland, right? So many people know Jerry Fios. What they have done is taken their system and they fully integrated it into a manufacturing process. It's not hard. It's pretty much simple framing machines, cut machines, but they have dialed it in with such precision and they made a system. Floors, walls, and the ceiling. And of course, the giant in the room, Autovol, that's the next route. I mean, that's the big player out there. That is the big boy on top of the podium, as they say. But the thing you have to understand, that's not achievable for everybody. And the difference with what they have done and why they have done it, they knew where they were going. That's the lesson. They understand their market, they understand their product, they understand their process, and they also understand who their customer is. That factory yard is so full that they're already looking at multiple other factories. Think about that. And I think that's the lesson for a lot of people in here to learn. You have to know and understand your market, your product, your pipeline of your customers. And if you know that, you can then determine the direction of where you're headed. Crate modular. I don't know if anybody's heard of crate, but here's a simple concept of somebody that has taken incremental automation to the next level. They started off just taking containers, modifying them, and now they're building full volumetric modular steel buildings, but they did an incremental approach. Those buildings used to be the containers, and you can see them there. But now they've incorporated, cold form steel framing technology, and they've taken it one step further. Trying to go fast, Cindy. I'm so trying. All right. So what's changing the way we build? Our supply chain is a disaster. How many people are going to have a hard time getting products around the world, right? It's a disaster. So what is changing? Obviously, the new entrants that are coming into the market is what's changing. So when we look at Bamcor, Hemplock, Broad USA is using stainless steel to build high-rise buildings to include their floor system, no concrete, all stainless steel. Lightweight, 10 times lighter than concrete, right? RSG 3D with their product. And by the way, hemp, just so you all know, you can't smoke hemp. It is marijuana, but if you put it in your factory, I'm telling you now, you're not going to be smoking it, and your employees won't be smoking it either. But as we look at this, these products are lighter, stronger, more durable, more resistant, less embodied carbon. They're safer, they're healthier to use. I mean, a lot of the insulation that's coming out in hemp, you don't need to block it off, wear respirators, none of that stuff. You're not spraying it, it's not fiberglass, but it's sustainable and it's moving things to the next level. Digitization. Products and process, right? Improve on-site collaboration, transform how we buy and sell, and how are we going to optimize the supply chain? We're talking about parametric design, generative design. Is anybody out there using any of these technologies now? I know a couple of you are. I know Bryden Wood here is using it. I just saw it this week. Right? You got ArchiStar, you got Creatomus, you got Creo software, you got Slate Technologies, which is super cool. They're using AI, artificial intelligence, to help you design. Can you imagine if you're drawing something out and your computer says, no, you're messing this up. Fix it here. It'll work better in this format than that format, and it'll go right down the production line. That's what's kind of going on right now with machine AI. And then you got Manufacton, you got ModuCore, which are ERP solutions in the modular space. They are taking all the knowledge of what they've learned, taking the bomb of your manufacturing process, and they're putting together end-to-end solutions. And this is key here. Nobody's really done full end-to-end, and we're going to talk about that in just a moment. Who's embracing these technologies? Buy a build. Anybody here buy a build? It's kind of cool. You go on their line, just like Tesla. You just pick your house, your color, hit order, and the house ships to you. It's pretty amazing stuff. You got builds, you got full stack modular, you got volumetric building company that has been partnering with everybody to grow bigger and around the world. And they're all looking at productization. How many people in here are trying to productize their product? Anybody? Right, a few hands. This is so important to look at how you are bringing value to the supply chain. Value to the supply chain is super important. Apex Wiring. Anybody hear of Apex Wiring? And I know I'm probably running on time, so I'm going quick. Apex Wiring is wiring modular. They said, we're not just going to supply the wires anymore. We're going to do all the wiring for your building. You're going to send us the plan, send us the wiring diagram, and we're going to modularize it. It's click and play. It comes in a box. You just put it in your factory or on the job site. It's amazing stuff. It's quick, it's efficient, and you don't have to have too much skilled labor to do it. You got Harris Mechanical at the bottom. I'm going to skip a couple of these. Harris is one of the largest MEP contractors in the United States, union-based. That stack over there is the stack to a multi-story building, all the mechanicals, MEPs, running right up to the center. And not only do they do that, they do horizontally as well as vertically. They've modularized their system, and they will come in your factory and put it in, or they'll come on the job site like that and drop it in. They work with you as a partner. And that, my friends, is how it's starting to happen. Who's out there challenging the status quo? A-fold houses we have in Italy, Boxable in Nevada. They raised $100 million crowdsourced private money. They just raised it. Foldable houses. Gropius. I don't know if anybody knows a Gropius in here, but they are doing some very high-tech automation in their factory. But the great thing about Gropius is, as well, they've actually included their own operating system. All of their buildings talk to them. That light goes out in the hallway. You don't call the supervisor. That data goes straight to the maintenance person. Straight to the maintenance person. But they're collecting this data. You're not using those plugs. They'll know on the next building not to put plugs there. They'll put more plugs where they see people using them. Now, you may say that's a little intrusive on my privacy and all those things, but this is where it is headed, and this is what we need to pay attention to, and we got to look at it. You guys are going to find out, if you're not already, data is king. That is what's starting to happen. We're starting to look at data in this industry like every other industry looks at data. Boxy, love this company. No automation, building inside a factory. Two 25-year-old brothers in the heart of Louisiana think this is the coolest industry ever. They call me Mr. Dave. They say, Mr. Dave. Good to see you, Mr. Dave. And I love it. But they are looking to incrementally grow their business to the next level, and they're challenging the status quo of age. There are other young companies out there around the world that are doing similar things to the Boxy brothers, and we need to celebrate it, and we need to present them whenever we can. TGE Construction. Anybody ever hear top-down building? They build everything on the first floor. They bring in their modules, they bring in their bath pods, they put it on the floor, and they lift the entire building up. Top floor first. Start the next floor. They bring it all in, put all their modules, all their pods in, and they build from the top down. Lift it up, lock it in place. This is the technology. Essentially, their assembly line becomes the first floor of the building. Broad USA, talked a little bit about them. They're using stainless steel. They have a flip technology. You can see how one box flips into another box. Others that are challenging the status quo. You got Fading West and Audubon. Audubon's in here a lot because they really are pushing the boundaries. But what's different with them? They're working with developers. These are two companies that have figured out their pipeline, and their pipeline's developers. You look at ModLogic, Bud Invest. We got Christoph sitting back here. Raise your hand, Christoph. Right? Christoph, he's doing modules, light, steel. He's doing wood, furniture now, I heard. I mean, the guy's doing everything. But partnering. He believes in collaboration. He travels around the world to meet people so he can work out partnerships for their business to grow and succeed. And then you got the Polcon Group, volumetric building companies, and they have formally joined forces with several other manufacturers out there. Also challenging the status quo. We got Bryden Wooden here sitting right in the front. We are at their facility on Monday. You should see what they're doing with technology. And they are partnering with builders and developers to take their businesses to the next level and help them improve their process and do it in a way using technology. Using technology. M&AR on the left. Anybody ever hear about quarterbacking your projects? What they do, they not only design your project, they make sure your project's going down the manufacturing line properly. They make sure the job site's running properly, and they deliver the project to the customer. Frameclad, where's Mark? I loved my visit to a lot of these manufacturers here in England because there's so much innovation happening everywhere, and I added a few things, right? So FrameClad has 2 manufacturing facilities using light gauge steel, Howick machines, but they're taking it to the next level. They are adding value to the supply chain. We go back to that value to the supply chain. How can you take what you have and make it better for the next person in line for them to use? They have product, they have process designed into their system. They can do bespoke products, or they can do the biggest projects out there. And that is what they're good at. And then we were also at British offsite, climbing up and down a high-rise building. I don't think everybody was happy with us yesterday doing that. It was hot, Anna over there. But with what they're doing, they have taken steel frame walls, panelized walls, and they've made a hybrid approach. Think about high-rise buildings. You got the concrete columns like you see around here, and they built a panel system to fit in between those walls that you can adjust any length. How wide you want them, whatever you want. It's quick, it's fast, it's simple. Imagine being on the 3rd floor, your 1st floor is already dried in and been dried in since the concrete cured on the 2nd floor. This stuff is impressive. Stay tuned for that video. It's going to be great. TLC Modular, Vietnam, Stack Modular from China. They're shipping all over the world. Z Modular, we were just talking about that in here. They have come up with a special clipping for their modules, their volumetric steel modules. Just sets down. You don't have people on ladders. Those days are gone. Modules set down, they clip together, done deal. Ah, you're lucky. How'd I do on time? I'm getting there. Listen, I'm going to leave you guys with something, though. I really want to leave you with this. Innovation is everywhere, right? And there's 2 things that I want to leave everybody with. Collaboration and sharing of the knowledge will be the keys to this industry's success. Collaboration and the sharing of knowledge will be the key to this industry's success. And this is something Brian Wood, I found out, also adopted. The technology to take your businesses to the next level exists. It is out there. Just find how it fits into your business and use it to your advantage. That's how you're going to grow and scale. We don't need to create wheels again and bread slicers and all that. There's process and product out there that we can already adapt into our system. So thank you for your time.
Now, our next guest, Lee. Now, I'm going to try to say your name. You can just correct me later. Chun Chi Lee? Ching? Chun Chi Ching Lee.
Yes.
Lee, for short. And I do apologize. I just like to be able to give it a go and just, say names the right way. Lee is an award-winning entrepreneur and the founder and principal of Creod Group of Companies. He is a vice chairman of the City of London Westminster Conservative Association Chinese Group, as well as a committee member for the Conservative West End Ward and international board member of Creative Industries Federation. Creod is a visionary brand of pioneering interdisciplinary architectural design, innovation, technology, and development companies, defining what they do as digital master builders. Creod developed the integrated design for manufacture, assembly, and I'll start again, design for manufacture, assembly, intelligent automation, KIDIA, application software to create changes in AEC industries. Founded by Lee in 2012 and based in London, team members come from a range of diverse cultural, educational, and geographic backgrounds to work in a highly dynamic professional environment. Let me just make sure that this goes to that. Next time, remind me. I give you Lee.
Hi, good afternoon, ladies and gentlemen. My name's Cheng-Kwing Lee, aka Lee. I'm the founder. I'm glad to be here, first of all. Thank you for having me, Nick. And I'm the founder and the CVO of Creod Companies. The first question people usually ask, what is Creod? Some say, you create something odd, Creod. Yes, we do, actually, but just in a very nice way. Actually, Creod is a multidisciplinary architectural design, technology, and construction companies. And It consists of, and we use design innovation technology to create changes in the AEC, architecture, engineering, and construction industries. The Creole brands consist of award-winning architectural practice. It's called Creole Architecture. And we have a startup company called the Creole Integrated Smart Solutions, KISS. And under that brand, we have formed the Creole Integrated DfMA Intelligent Automation Tool software. And following that, because we do the digital assembly simulation, so the question is, what can builders do at can't? So it turns out we're the contractors now. And we're also, using our own technology. We developed the building systems called the Creole Aeronautics Building Systems, CAPS. So we're launching Creole Homes, which is going to be fully customized, parametric, and ready for fabrication with a clear costing and deadline, etc. So firstly, I'd like to share my personal story. It's the Creole London Olympic Pavilion, which I designed and built for the Olympic Games back in summer 2012. It all started with an idea. My background is computational design and digital fabrication, which is still playing a very important role in the AEC industries. So following my studies, I came up with this design. It's a pavilion. And when I asked around, I wanted to build it. When I asked my colleagues and the teachers, they said it's impossible. Why? The reason because I was a young graduate and I just simply didn't have the recipe of success because so much I didn't know. And there's a real world out there. There's so many challenges. So the question arises, who is the client? Who's going to pay for this? Where do you build this? How to do this? Who's going to solve all the design problems? I couldn't answer all these questions, but I firmly believe I can do something. So I transformed from a student into an entrepreneur, started pitching, a range of companies. I sent thousands of letters, spent £2,000 on stamps and envelopes, pitching this idea. After thousands of attempts and failures, I've managed to convince a range of companies who believed in my dream. So they kindly sponsor their products, services, materials, and also the land outside the O2 arena. So this is the pavilion I designed. It's a movable kind of structure. It consists of 3 identical elements on clusters, so you can push them around, creating different types of exhibition spaces during the day. At night, you can push them together. It glows in the dark like a Chinese lantern. It also secures itself. So each pavilion it's a very small job. It's super complex because it's double curvature. And each pavilion consists of 997 unique pieces. Imagine if each member is 1 millimeter bigger, 997 pieces later, there's a 1 meter off. So you could never build this. So when I asked my engineer, how much would my pavilion cost? They said it's going to be £1 million. I was so surprised. So why? Why is it so expensive? Because it's the level of complexity of this kind of project. Look at this young man. The O2 arena behind you was £380 million original budget, and the final cost was nearly tripled. Based on your experience, if you've never built anything in your life and you're trying to do something like this, good luck. I wish you success. That was the comments I had from my colleagues. And so this is the very complex project. It was our first attempt. It was a fully paperless design, engineering, manufacturing, and construction. And gives an idea. Oh, sorry. It gives an idea. The steel plant. I closely work with the steel fabricator, and even understand the chamfer for welding, and give the 100% detailed model. I didn't understand the term. I didn't know the term DfMA, Design for Manufacturing Assembly, but I called it Design Information Manufacturing Modeling. So and so this is what's was it play that? That's how it was made. Because each member is cut in 3-dimensional angle. It couldn't be made by hand, and the accuracy needs to be aerospace accuracy, plus minus 0.02 millimeter. And the only paper we had was this A3 assembly diagram. I didn't want to bring my shiny MacBook Pro to the building site, so now we can use these iPads. And we successfully delivered these projects. And actually behind the scene, I created a new workflow. But the workflow is very, very complicated because it requires a very specialist skill, the programming, scripting, and then from the knowledge sharing and the product life cycle management point of view. This is not transferable because each designer or with a computational design, they always come with a different solution, the same outcome but a different journey in terms of programming. So I found this very difficult to manage. And also from the business point of view, you can see this kind of a job, it requires a special skill. And that's the risk, So I realized that I must come up with a system so that you can automate the process so we can focus on the business growth rather than the dependencies on a highly skilled people, which is very, very dangerous in the business world. And from that, we started looking into the housing developments. And I must thank Nick and his colleagues from Howick, and also my engineer, Nigel, Ideas Global. My structural engineer specializes in light gauge steel frame. So we've been in the background developing an automated light gauge steel frame software on Dassault systems. And this is a job we were involved working with Nigel closely, and also Nick. We've been doing this automation. So the principle is, just automate the process, really. I think this job it can be easily generated in, computer does the job, which is 3 clicks. And I would say it was 3 hours. Yeah, we can change a better computer. And the principle is very simple surface. This example, a surface or a solid, a block. So it generates a wireframe so I can pass it to my engineer, Nigel, to do the structural analysis. Once we can replace the stick models, it generates 100% detailed steel frame. And also in the background, it automates the drawings, which I don't need. It's just for the building control, and more importantly, it's the manufacturing code. So I can pass it to Viri, the Wallenmauer manufacturers based in Lithuania. So in this way, we in control because, the steel frame itself is just the beginning, actually. We need to consider the facade systems, the brick slips or cladding panels. So I have invested and developed a range of automation tools. For example, this just a random surface, So you just click a button. It tells you we need 7,300 bricks. So the steel frame for Howick, just manufacturing code, we can give it to any manufacturers in the world. And the rest of it, built for materials. So people always ask me, how much? How much does a building cost? How do I suppose to know? I can't tell you. But now, actually, it's an informative design approach from concept design or the RIBA, the beginning of the RIBA stage 2. We can immediately arrive to the end of RIBA stage 4. So if you're the brick slips, site and concept, we might consider other cladding panels, say steel panels. But the steel price has doubled since the beginning of the pandemic. So we might consider a composite cladding systems. So this kind of informative design approach, it gives you certainty when you're running a business as a developer. Because once you decide the material, say Kingspan cladding panel, but now the price has doubled, suddenly your project is no longer viable. But if you knew this, you can do an educated guess what's going to be in the steel price in the next few years. So we can think, we're going to use the composite panels because the pricing is not jumping too much. So once you've got the planning permission, it's not that easy to change it. So this is the solution. We work working towards the developers as well as the principal contractor, building a range of buildings, residential developments in London, and there's potential an apartment block in Birmingham as well. So this is the job. We are the principal contractor. So we provide turnkey solutions. So this is one of the ugly projects. My investor bought it with a land with a planning permission, and our job is so many roles as a turnkey contractor, lead architect, project manager, and the principal contractor, and also the MEP contract. That's another challenge. I'm just it's a very steep learning curve. I never understood why this industry worked in a way. But anyway, we're solving problems step by step. So this is the, risk assessment, really. We don't use any drawings. We had to produce a drawing for my subcontractor, the basement contract, setting out drawings. But as you can see, the site is very, very tight. You've got the illegal basement developments next door. We just don't know where they are, how deep they are. We didn't know the condition. We did a point cloud scan, which is 12 gigabytes. And initially we had this a ground beam on the site. And I realized that's just very risky. Even if we did the 12 pits, we dig down. And actually, the internal wall is 107 millimeter away from the boundary line. So if we build a trench, it will crash into their building. There will be some claims in the future. So before the construction started, we saw the problems. We changed the design. It just keeps us out of trouble, keep everyone out of trouble. And also the construction simulation is very important because my background is not an architect, really. We design buildings, and we're not building contractors. So we do using simulation assembly sequencing. So we understand from the detailed 3D, it drives Gantt chart program. So understand any changes, any impact. You can see the dependencies a month ahead. So it puts them in a really, really strong position. Understand it's all about risk management at the end of the day, finance as well. So we program everything in terms of logistics, how things go, how things run, which is going very well. And this one we're finalizing detail with my structural engineer. So we just automate the process. Another thing is the MEPs as well. But the current issue with all this framing software, Techno, anything. The problem with them is they want the final design, but the problem is the final design doesn't really exist until we get the MEP designs because it clashes. So the thing is, the current software we have in the market is very, if you want to make it change, it's quite tricky. So for us, it's just a few button clicks. I'll show you some more examples. So we can understand any design changes we can just change accordingly because it's fully parametric from the steel frame, the building envelopes, internal fit out plasterboard, how many sheets of plasterboard, boarding, everything. So that spits out the cost, a spreadsheet, shopping list. So what I'm introducing here is open book contract. Costs, this is my labor, and this is our profit, which is 28% profit on the construction is really, really high because of the efficiency. And we don't need people. That's the beauty of it. And this is another case study we did. This is the primary house we designed. We had 2 architects before us, both from Grand Designs. It's a greenbelt development, and so they didn't get a planning permission. So we came along. Yeah, we're very good at plannings as well. So we got the planning, and it's a private house, really nice actually. The cost for this, actually we changed the design, and even double high sliding doors. So the price of this job is £180 per square foot. It's pretty high end. And entire simulation, automation simulation, that gives an idea, so from the concept design, our Create tool, automation tool, and it clicks in the garage. Very conceptual design, reference surfaces. You click on the panel, in seconds it generates 100% detailed cladding panels. And you click again, it will generate all the cladding rails. So the way we program is it definitely going to work. If it doesn't, it won't generate it anyway. So there's a engineering template we created. And as a behind the scene, it generates manufacturing shop drawings, manufacturing code if you require. Anything quantifiable. It just gives us spreadsheets. How much people are interested. So this is a level detail, fully automated. Maybe some manual tweak, but pretty much it's just a click. So the idea is my receptionist can click and do the job without realizing what's been done, but its job is done. All we need to do is due diligence. Check. Is that okay? It should be, yeah. Just double check. And this is the envelope, just the envelope itself. The building we changed 12 times. The beginning, we didn't have the budget for the underfloor heating, and the client wanted, because they're private clients, and they wanted the roof pitch to be steeper. They want to see different options. And if you work in the traditional way, you're the architects. You produce design intent. You give the appointed principal contractor. Principal contractor needs to hire a facade engineer. Facade engineer needs to work with a manufacturer. So if you make any changes, the chain and effects, people want more money, need more time as well. So that's how the relationship goes pear-shaped, So now we have this solution. We made the changes in the front of them. You click, 7 minutes, no hard feelings. What else? So 12 changes. It automates everything. And last minute, we have the budget for underfloor heating. Good news. Not good news for us, but yeah, it's okay. We have the software solution. And there's a digital mock-up, So we need to understand how to assemble them. Every single part is it's a digital twin to the real world. And this is our engineering template when we created this, ready for manufacturing, we created unfolded drawings and everything. DXF, if you need it, or just CNC, spreadsheets, manufacturing codes. In terms of bending parts, it's a K factor. Obviously, different manufacturers have a different bending, different machines. We just need to double check. What's your bending K factor? 3.728. Yeah, we just change that. Automated. Job done. And steel frame, light gauge steel frame. And yes, this is the final, the entire building envelope. Assembly drawings, it tells you how many different panels and the quantity. Shop drawings, all done, automated, by the way. We didn't touch anything. It's done by itself. So that's the beauty of it, efficiency. And also, how do we build this? People don't understand. They don't have the real skills, in unconventional construction methods. So we develop just very, very simple tools. It guides people what needs to be assembled. So it could also simulate the construction process. We know how many people and how long it's going to take. So what we're promoting is very liberal approach. Is if your job during the next day like this, in theory, Lee and Nick can assemble 5 panels. If we did 10, we'll be double paid because we encourage you to work faster or pay more. But ultimately, as a building contractor, it doesn't affect my budget. Is the job is done much quicker. People are more encouraged. So win-win scenario in the case. And yeah, this is the work we do. Thank you very much for listening. Thank you.
Scott Mitchell from Stud.io. He is the founder and CEO of Stud.io, a computational construction company. Before founding Stud.io, by the way, I need to ask Scott what IO means, and I'm sure you explained that, right? No? Okay. Before founding Stud.io, Scott worked as a full-stack software engineer at Autodesk as part of an AEC generative design group. While working at Autodesk, Scott has access to a Howick roll forming machine, which he experimented on in his free time before ultimately leaving to focus on that interest full-time. As a student, Scott studied film, music, architecture, and computer science. In other words, making things. He still enjoys composing for the guitar, producing videos and animations, and experimenting with software development and fabrication research at the Autodesk Technology Center, where he is a resident. In the past several years, Scott and his wife and their golden retriever, Lou, love it, have lived a somewhat nomadic lifestyle, traveling to and living in various cities across the United States, including Boston, Massachusetts, Los Angeles, Austin, Texas, Tulsa, Oklahoma. They now have a 6-month-old now. That was 2 months ago when this was written. 6-month-old son, James, and are based out of Boston, but probably going to move soon. Yeah, but I'll let you tell everyone about that. I'll give you Scott Mitchell.
Thank you, Cindy. Thank you all for being here. Like Cindy told you all, I am Scott Mitchell, and I'm the founder of Stud.io. Our mission at Stud.io is to enable architects to build some of their boldest ideas. And a lot of times that means geometric complexity. And we enable that by inventing new parametric fabrication systems and then developing the software to automate the design and fabrication of those systems. So Cindy gave you a little bit of my background, but the story I'm going to tell starts with the Howick machine. So before founding Stud.io, I was a software developer at Autodesk. And before that, I was an intern at Autodesk for a summer. And they basically, day one, showed me the Howick machine. And they said, we just want you to spend your summer seeing if you can do anything cool with this machine, which was an awesome project prompt. But at first glance, I was like, this machine just does one thing, right? It just makes studs and punches holes in it. And it looks like people have pretty much figured out everything you can do with that machine. And for those unfamiliar with the Howick machine, it rolls up steel studs and tracks, and it punches holes at some point along the length of it and then cuts it to length. And the machine I was working with did these 8 punches right here. But after diving into it for a couple of weeks, I started to realize that you can create some complexity and things people hadn't thought of before based on the simple, basic operations that the machine is capable of. And this right here is really foundational to how Stud.io operates, how it designs things, and how it develops software. So CNC machines have basic operations they're capable of. We develop software that understands constraints around connections that apply operations to members. And these connections get aggregated into versatile systems that you'll see a couple examples of here in a second. So let's look at connections first. This one's a pretty useful connection. We call it the handshake connection. It's basically 2 studs back to back. If you take that 3 web hole punch on each one and overlap one of them, and then do that again on the other side, put a screw through those alignment holes, you fix 2 studs at some particular angle, whatever angle that is that you want it to be. And also notice that connections have constraints. So 2 studs that are back to back, the constraint is they have to be facing in opposite directions. So the software determines the orientation of members and then applies operations to those members to make that connection exactly how you want it, 111 degrees or whatever, once you get it out of the machine. So then if we look at combining connections into systems, so this is a pretty typical connection. You get 3 members, stud to stud, dimple connection. That's flat though. But if you bring in the handshake connection into the structure as well, you can start to break out of the plane into complex geometry. And as you expand that in a series of multiple different connection types, you can start to do really interesting things. And so this is actually one of the first systems we developed. It's a reciprocal structure. We saw an early version of that a second ago. But the idea here is that ultimately you can feed in any surface you want, any complex surface, whatever, into the software, and it tessellates this pattern across the surface, and you have all of the unique members that you need to go build it. All the holes are in exactly the right places. Basically just use the Howick machine to create your Lego set and go put it together, and it matches your surface perfectly. And it works. We've built a few of these things, basically just trying to do interesting geometry. This was an installation we did at AU a few years ago. This is another one. What's really interesting about this one, it was at a party. The bar was inside of what we call the Space Igloo, which we thought was pretty cool. We showed up the day of the party, created our files, created our parts on the machine with those files, and built the thing before 5 o'clock when the party started. So getting back to this, you've seen how the simple operations that the machine is capable of applying very precisely can generate complexity if they're combined in the right way. And this is really where a lot of the creativity happens. And it reminds me of other things that I've done in my life, like games or like chess. It's almost like the operations that the machine are capable of, which are really simple, like your pieces. So the pieces in chess aren't very interesting alone, but they have moves and constraints on those movements. And it's how you combine those moves to create strategy that's really interesting. And the same thing's true with music. Your notes are sort of the atomic level of music, which have constraints, like Western classical music implies constraints for how you combine these notes into harmonies or into chords. And of course, you connect those in time to create compositions. It really feels the same way with what we've done with the Howick machine over the past few years. Basically starting with something simple and a system of rules and constraints, as well as an understanding of when you might want to break those rules to create really interesting stuff. So I think what's unique about Stud.io is that we play the Howick machine like a game. We play the Howick machine like you would play an instrument. And the reason that I feel that's valuable is because CNC and digital fabrication equipment is designed with some set of use cases in mind. And then people develop off-the-shelf software to support the process of using machines in some way. But really, I think that's just a small subset of a lot of latent potential in pretty much any CNC machine and Howick machines in particular. And I think the reason that people aren't in that other vast space is it takes one, curiosity and playfulness and a willingness to experiment, and those experiments potentially fail. But also, your own design tools. We're developing software that helps you to move more feasibly, more quickly through that space and explore it. And so what we're doing is slowly expanding the capabilities of the machine. So there's like this boundary of what's feasible. And we do experiments all the time that don't have any immediate tangible value, but they're just pushing that boundary outwards. And if they're not immediately valuable, they almost always are at some point down the road, either leading to another idea or it's an actual thing that we use on a project. So I think if you made a map of like our capabilities and our software's capabilities currently with the Howick machine, it's this growing, like amoebic, branching, just like really interesting exploration into the space of potential of the machine. And one of my favorite examples of that is curved studs coming out of the machine. And the reason that's my favorite example is, to the best of my knowledge, the Howick machine wasn't designed with that feature in mind. Okay, that is correct. It just happens to be possible with the features that it was designed for. So it's meant to make straight studs. It happens if you use a couple of those operations in a unique way, you can start curving studs that come out of the machine. And the way that works, it comes out straight. We're using this end truss punch that's typically at the end of a stud in the middle, as well as two dimples on the side of that. And if you snip one side of the end truss, overlap those holes and put a screw in it, this thing starts to fold up into a predetermined shape. So not just a circle or an arc, any sort of curve that you want to create with the stud, you can do it. It's just about where you place those holes. Some other experiments we've done. This one was before I founded Stud.io. For like a month. It was another party that we were looking to create some cool stuff for. It's usually an excuse to experiment. We wanted to build some cocktail tables. So for like a month, I'd get home from my day job and just like sketch and then use our software to design weird cocktail tables using the Howick machine. And I probably did like 30 or 40 of them, picked 10 of them and built them and had drinks on them, which is pretty cool. So I like that part of it. I think there's two reasons I really like this, and it's almost like one of the proudest projects I have, even though it's a small one. Like, first of all, like pretty sexy tables. And second, it's this library of connection details that we can pull from and still do pull from on real larger projects to this day. Another thing we did that definitely didn't have any immediate tangible value was we built this bird. And the reason that we did that is thought it would be cool, one. Two, we have this system we call a faceted surface system, usually for large architectural applications, but had a feeling that we could do highly articulate surfaces, like the geometry of an animal or something. Take that to a music festival or something like that. So just to prove that was possible, we built this bird, went together pretty quickly. And some of the detail that I want you to notice, because this is still that architectural system, just trying to proving what's possible with it. So if you look at some of the detail of the faceted surface system, there's kind of this like interlocking frames at the chest plate there. You should see pretty much the same thing here. So this is the same system, but just applied architecturally. But we did this, usually the facets are way bigger. So we did this after the bird, after we kind of proved to ourselves, we can actually do super articulate types of geometry. And that was actually an interesting project for other reasons. So they wanted to be able to disassemble it and reassemble it at a number of different events. And one of the events, they had to take an elevator to the space that it was going to be displayed in. So each of these, we broke it up into 19 modules that had to fit into an elevator so they could be bolted together on site. And this thing actually goes together in like an hour, so not too bad. Then you can see the finished product on the right. I'm just going to quickly go through some other projects that we've done. This one was a museum in California. There were 193 unique panels. Here's a couple of them, but just super organic custom shapes. We developed a system that could generate their framing, as well as a whole bunch of other deliverables, including the GFRC molds that they got cast into. This was this crazy curvy surface, relatively small project, but probably the most complex thing that we've done, but ended up working out really well. And this is actually an earlier version of the faceted surface system I was talking about a minute ago, but just showing you guys what it looks like in an architectural application. So that's kind of the theory behind what we do. I want to, a couple minutes remaining, show you how we provide value on projects based on this history of playing around with digital fabrication equipment. So this is the Sphere in Las Vegas, and we were brought on to help with what's called the collar. So basically this ring around the bottom. Just a couple quick things to note about the geometry of the scope. It's obviously curved in plan. It's also sloping in elevation, so there's some engineering constraints around different height panels. And then most importantly, and we'll get into this in a second, like it is tilted in section. And that tilt is variable. So it's kind of tilting out, coming back. So that changes as you move across the collar. And we looked at a variety of different systems. The system that we ultimately ended up applying to the scope was an EFIS system, which has frame, sheathing, foam at a high level. Those are the components of it. The main thing to take away from this slide, though, is all the components of that system are flat. And we obviously didn't just look at flat geometry. So a big part of what we do is we come in and it's like, okay, based on all of the software and the capabilities we have, how are we going to build this? And start to explain it. Let's start with something simple. So a flat wall. It's pretty easy to make flat panels out of that. Even if you tilt that wall out, flat panels, rectangles, easy. You start to see issues when you go around a curve. So these things are, so issue number one is that they're fanning out in elevation. So you get this gap at the top, which is not good. To fix that, you just move your rectangles to become trapezoids, fill in that gap, we're good. Issue number two, remember that tilt wasn't constant. So if we want a variable tilt, let's say it's 80 degrees on the left, 60 degrees on the right, we see issue number two, which is that these fan out in section as well. Which was not the design intent, so that's not good. And even on a straight wall, that's a problem because they're kind of incrementally leaning down. So what you want to do is you kind of want to like push a corner to its neighbor so that it's all lining up. The problem is it's obviously not flat anymore. But that does at least give you a controlled approach to panelize the surface. But we didn't stop there, so we continued our investigation and realized that the top and the bottom circle that are defining this thing also define a cone, or an oblique cone specifically. And what's good about a cone is it's basically a pyramid with a bunch of sides that are flat. So if we run our joints through the apex of that cone, we have flat panels. The downside is that our joints are running through the apex of that cone, not necessarily straight up and down. So it's basically this trade-off between flat panels, kind of weird joints, or do we want twisted panels and the original design intent joints. So we can really quickly run this stuff through our software. And these are kind of like prototypical panels, so not full scale, and ignore a couple other details, but we can evaluate and show the client what that looks like and what the system would be. So we have conical on the left. Obviously the joints look a little weird, but we can do it, and all those parts are flat off the shelf. Or we have twisted on the right, which is what we ended up going with. And what we did is we kept everything flat behind the foam, and the foam has a flat backside and a twisted front side. And it's among the deliverables, like files we can export from our software, includes CNC files for like a hot wire cutting. So we just move the complexity of the twist to the foam. So then looking at what that actually looks like applied to the project, developed a system, an automated system for that specific project. And obviously you have the frame, you have the handshake connection to get a horizontal frame on the bottom so you get the right tilt. They also have alignment holes between this brake shape and between the frame on the bottom to get like this brake shape on the bottom that you use for layouts, like super precise layout onto these pins. Obviously you have the sheathing, and then you have the custom foam, which, like we said, is variable thickness, right? So those things have to be digitally fabricated and well controlled. But again, once that system is put into place, it uses our software inside of Grasshopper visual programming. You just run the panels through it, and you guys don't need to see all of them. But at the click of a button, once you have that system applied to the project, it's just export various files, including files to the Howick machine, files to assemble the parts coming out of the Howick machine, stuff for the hot wire, stuff for layout, etc. So that's basically it. This video shows proof that this actually works. Basically just shows all the details I was just talking to you about. We've got the frame comes out. Frame drawings are automated as well. And they put these things together. You guys are probably familiar with most of this process, but I do think this is pretty unique that each panel had a different angle, right, that the frame has to tilt out at. So that handshake connection at the bottom gets you that, and it takes the people on site no time to put it together. And they don't have to get a protractor out or anything like that. It's just line up the holes and put a screw in it. Then that brake shape, again, it has alignment holes from the brake shape to the frame as well. Which I think is a tactic that we use all the time. The Howick machine produces such accurate frames. We can basically use it as a jig for other components. So we can include alignment holes or registration holes on the frame that other parts are registering to. And then one thing that we've gotten into recently is a digital install as well. So exporting files for, this is a Hilti total station, basically pinpoints exactly where those pins that were going into the bottom of the panel are supposed to be, and then also gives you points on the finish. So when they drop this thing into place, they can check to make sure it's in exactly the right place. So there it is. This one's going up right now. But anyways, that's how we apply what we've learned to actual projects, and this is the kind of stuff we're doing now. So thank you all very much.
Our next speaker is Nicola Moriarty from Bryden Wood. Nicola Moriarty is a director at Bryden Wood, a global company of creative technologists, designers, architects, engineers, and analysts. She is a chartered structural engineer with over 25 years experience in the construction industry, leading teams with multidisciplinary projects from conception to completion. She has a passion for DfMA and how this approach can lead to successful delivery of projects. She was involved in the early forms of DfMA in the volumetric modular approach to student accommodation, and more recently on the Forge, where a combination of DfMA and other MMC approaches have been implemented on this groundbreaking commercial development for Landsec. Nicola is a keen walker and skier, along with recently developing a passion for sailing. Amazing. A hobby that lends itself nicely to her other love, which is traveling. I give you Nicola Moriarty.
Good afternoon, everybody. As Cindy said, I'm a director at Bryden Wood, and I'm here today to give you an overview of our project at Southwark, taking the platform approach to DfMA. So, first of all, what I want to just run you through is a bit of a sort of an introduction to platforms and how we see them at Bryden Wood. So, no doubt many of you are aware of the Billy bookcase that IKEA has sold for years. They took the philosophy of, instead of building a bookcase themselves and transporting a large volumetric object, it was far better to reduce it down to components. This reduced the amount of storage needed in their warehouses and made it more transportable for the end user. It's simply erected when the end user takes it home, usually erected right next to the place where they need it. Bookcase, as we know, comes in several sizes, and it's generally only small components that need to be changed to alter its size and shape. So at Bryden Wood, we're taking that same philosophy and applied it to building types. Depending on the height and clear span of what's required for a particular building, it determines the type of platform that we can use. But as you can see, there's generally lots of overlap between the system to provide flexibility. By taking this approach, we're also in alignment with the government's roadmap for 2030. And as you see, we aim to create a kit of parts that can be manufactured in high volume and high quality. But what are the benefits? So we find that we're getting less material. So the associated costs with that, the carbon, the transport, we've got fewer components. That gives us the economies of scale that we need, levels of optimization, the distributed resilient supply chains, and greater control of logistics and trading on-site activities that we're all aware of that's quite a challenge at the moment. And also we get standardized processes, so in manufacturing and assembly. So this enables us to have a diversification of the sector, so we can upskill non-construction personnel, which is very important in this market that we have, with challenges with getting the right personnel that we need. Improved health and safety, which is key. Increased productivity, reduce reliance on trades and workmanship, and promote the automation. So how does this actually apply in practice? Well, we are just currently coming to the end of our first project, really sort of pushing the boundaries on this in the Forge in London. The Forge is situated in Southwark, and it's a commercial building that we're just completing for land security. It's 2 buildings in a very, very tight site. As you can see from here, we are on the South Bank, very close to Tate Modern, and as usual for anybody that knows the construction anything in London, we are bound. It's really, really close boundaries on each side with really only one access. So the kit apart and the platform approach really suited this development. Not only was the approach to DfMA led, but also design to value was a key driver too. We also had to ensure that we adhere to the requirements of the client, because they've got these very, very strict design requirements that they need that actually go to their end user. We also had a planning grid that we needed to adhere to, and also had to be something that was flexible for the MEP that we're actually putting in it. So the platform approach really did allow us to really carry on with what we needed to do. So the actual system itself is the structural frame just utilises very general construction products. The steel beams are fabricated with openings to allow, the passing of services to reduce structural and services zone, shear studs to allow a general composite action. But then we've got steel shoes that we actually fabricated on the beams that actually sit ComFloor beams. So all that we're using is a general ComFloor lightweight decking, just in a different way, so that we've got a shutter, in effect, that we can put all the reinforcement in and just lift it into place. So there's no additional sort of bolting or fixing required on site. The downstand regulator, it's on a regular pitch, so using the ComFloor in this way, the actual floor spans are reduced. So the floor slab reinforcement is then known in mesh, which actually went up with the shuttering system. The floor slabs, we constructed them with sockets already installed, so that really sped up the MEP installation. And the MEP was roughly in 4 different modules, so really keeping the repeatability we were 8-story building, so that it really sped this up. And something that once one floor was done, the operatives were just straight on to the next. It was getting quicker and quicker. So we've really had a lot of success with it. On this image, you can see that what we've tried to do is keep this kit apart. So the different colours just show the different parts that we had and just repeated them. The blue, dark blue and the light blue beams are the general fabricated beams with the holes in to allow services. The gold is just structural hollow sections for very, very narrow, but a regular grid that was easily lifted into place. So, nothing huge, and things that the contractor, all familiar. This is, these are all construction products that we're used to every single day. So, as this was a new approach, we carried out several prototypes. Here on the left, you can see that one of the first prototypes that we did with the actual Ministry of Justice, we actually worked with them to look on their prison portfolio to see how we could speed up construction for their new rollout. We actually worked with them with some prisoners on one of their facilities to actually give them skills and to see how easy it would be to train a non-skilled workforce, which was really great. This image on the right, this is actually the forge. So this is showing you the actual shuttering tables that I mentioned earlier. What we've done here is we redesigned the shuttering that's reusable for every floor and for other buildings, but we've taken the propping back to the columns so that we're trying to speed up construction as much as possible to allow free open space along the floor plate, which is it really, really does help when you've got a lot going on and you're wanting to, bring in, especially on a tight site, bringing up in extra materials. It gives you that freedom. Here's a video of us actually doing the prototype. So these are called ridge stackers. That's lifting the con-floor beams into place, as you see on the shoes. The operatives putting the propping into place. As you can see, it's very light gauge steel that we're using here and repeatable connections, so it can be put together easy and with little instruction. These are the shutter tables going up with just the mesh on for the reinforcement. We found that actually pumping from below a wet mix was the best way to do it to get a real nice finish. This is using an automated screeder. On the forge we didn't, we just did it a traditional way. As you can see that, it's not taking many operatives to actually, dismantle the shuttering as well from the flooring. And again, using these ridge stackers to help them, they manipulate the shuttering as we went. So it was really quite great. So as you can see, there's a lot of wet concrete going in there. You're thinking, well, why not maybe use precast concrete? Well, we did analyse this, but you're finding that you're just transporting more volume to site, which when we drill down to it, all this, precast laid down in the yard, lifting onto another material, transporting to site, lifting to position, it just didn't make sense to us. So we didn't proceed with it. We just kept to the wet concrete in that area. The sustainability benefits is just great on this. You've got highly optimized structure, so you can reduce the quantity of building materials, which give you fewer transport movements. It has this really great knock-on effect. You're reducing your building weight, your smaller foundations. Sometimes, especially when we're building in densely populated places like London, sometimes there are actually foundations there. Reusable, you possibly be able to reuse foundations, which is great. Then on the MEP, we took exactly the same approach. keeping it to as less as modules as we could, and repeat them throughout the actual building project. And with NG Bailey, using their facility, we just all off-site, so it all could be pre-commissioned to a certain stage, and that we could be, ensure that it could be just lift and fix, which was, what we ultimately wanted. The actual components, as you can see on the far left, we tried to get them so that they actually could fit into, the actual lorries that they were going to. That's, another consideration, that you need to make sure that you're not doing a great massive module that you're going to need road closures for. So everything that was designed to go back in the lorry, and then that it could be stacked actually on the slabs, going back to earlier. We wanted to get as much space on the site so that we could have these deliveries made, put in place. And again, using the ridge stacker to actually lift the modules so they could be easily fixed into place. But these were actually delivered in a just-in-time logistics method, which was ideal. You don't want anything sort of stacked up on your site. And as you can see from this image, it's all very densely compact, but it's making sure that we're not only have we got all the MEP in place and it's all fixed in place, but we're also giving as much height as possible to the end user. A really sort of important aspect. When it came to the facade, exactly the same principles were taken. We looked at the elevations, and we drilled it down to about 10 elements, all componentized so they could just be picked up and installed into place. We did simulation analysis with the CFD to just make sure that it was going to be, whatever we were going to do was going to be no overheating on the building at all. So, using all the information that we've got to just check everything all digitally. So there's been a lot of these recent months, as we've been coming sort of more into the project, we're working with the University of Cambridge. And we've had, as we know, lots of sites have webcams on. We've had lots of digital tools. And we're now analysing and how quickly, this job has gone up. The actual panels themselves have gone up in 7.5 minutes a panel, which is great. And we're also doing the analytics for the rest of the building, and also seeing, how we can sort of configure the construction process to make it quicker, and also see what went wrong, what was the hold-ups. This project was done, during the pandemic. We had, supply issues. It was definitely a major challenge, but, to say that we could, achieve that was, quite a feat. In fact, we were waiting for deliveries and some days coming from overseas. So what's the chain reaction of benefit? We're finding that there's a 30% reduction in embodied carbon on using this approach. And this is the first net zero commercial development, and we've had it certified by the UK Green Building Council, something that we're really, really proud of. And we're finding that, on this approach, there's a 13.5 increase in productivity. We know that there's lessons to be learnt on this, but it shows that it's a positive move for the industry. So, obviously, we're working with Howick, and which has been great, and we've really enjoyed it. So, but what have we been doing there? So, Howick asked Bryden Wood to actually study the feasibility of using their products in a steel portal frame building. And as part of this, we found by analysis using their sections, just use them in a different way, that we could actually go up to a 24-metre span of varying lengths, and generally in a 5.5 metre base span, which is really great. But all it is just using the product is already out there, and just thinking about it differently. I know that speakers prior to me are just doing the same thing. It's ready available product. It's great. It's this, by doing this, you get an efficient, lightweight frame. The positive knock-on effects is smaller foundations, which is no sort of small thing. When a lot of construction projects, the money is lost in the ground, and it's also less weight for transportation costs. Definitely compared to a traditional steel frame. It was just great to collaborate with Howick on this to see what we can do and take this further. So, well, thank you very much for listening to me. I hope it's given you a bit of an insight into what we're trying to do. Thank you.
Thank you, Nicola.
I have got a question. That's all
I
right.
don't know what to do now. All prepared for questions, Billy. Hold on. This is my moment of truth. There you go.
Hi, I'm Sam Stacey from Innovate UK, and actually I know a lot about the Forge buildings. We sponsored it, but I was interested by your productivity figure, which is in the right direction, but actually I would have expected a greater improvement in productivity. What are your thoughts about that?
Yeah, and we would have liked it. Yeah, we would have liked it, and we are actually going through the reasons why. We're finding that we had a lot of logistics issues. There was getting products. We obviously during the pandemic we had workforce issues that was a huge challenge. So what we're trying to do at the minute is actually find sort out the wheat from the chaff. Find out, if we had a perfect or semi-perfect sort of run at it, we didn't have the supply chain issues that we had, in products, things being stocked on site, how that would have changed it. And that's looking, quite sort of positive at the moment. So we're hoping to have those figures out in the next couple of months to actually show that. So it's, yeah.
Fantastic, thank you very much. I think there's a long way to go on productivity, and I think this approach has enormous potential, but I'm sure you're preaching to the converted here. But we need to get that message out more widely as well. Thank you.
Yeah, I have a question regarding the mechanical design systems. Did the Bridon Woods, did the DfMA for that system? That's a question number one. And number two, if you did it, did you have to use an MEP contractor to assemble it? And was it tested before the assembly? So this is three questions on one thing.
Yeah, great question. So we did do quite a lot of design of the MEP to get it into a modular format. But then we did work with NG Bailey and their production facility to just see how we could even improve it. Obviously, and they did do the testing in their facility as well. So it really did help to have a collaborative approach. They did the installation as well. So to have that, and that they are we found that NG Bailey are actually one of the contractors that were actually sort of quite open to doing this type of thing. So yeah, we took it to a certain part. We knew that we needed modules that could fit in the back of a truck. That we had certain floor service zone issues that we had to achieve. But it was a case of they then took it and they said, right, okay. They looked at what materials they could get, what they could procure more easily. So things like that were tweaked. But yeah, it definitely had to, I feel that it worked as a collaborative installation process.
The principal contractor?
No. So the principal contractors on this one was Mason McAlpine, and they were sort of like a construction management. Yeah.
Yeah, I think we're facing the same problem because we're building a slightly medium-sized project, and it turns out this MEP world is a wild west and cowboys. I found it's very so. luckily, we're the principal contractor, so we actually interview people, understand what you do, what the problems are, and join our platform and software. And then we do the 100% DfMA, we do this assembly sequencing simulation, understand all the logistics, when they're coming in, the best times coming in, etc. I think that works better. But if you work with the under the principal contractor, I mean, what was the challenge to convince the principal contractor, and then at the same time you had to collaborate with other manufacturers and suppliers and installers, and they've never done this way before, and they still prefer this old school 2D drawings, and we solve the problem on the sides anyway, that kind of stuff. How was your experience and journey?
Yeah, working with certain contractors, they still have a certain view. So to try and break down that view, you will find it tough, to say the least. But I think it's something that us as engineers, architects, the forefront of trying to push this. We've got to say to people, look, this is a good way of doing things. This is why, with what we've done in the Forge, we like to promote it, because we know there's a long way to go, but we think that by showing people that, look, it can be done and it is successful. We're not bringing in any strange and wonderful products here. We're just using technology to enable things, and I think that's the main key that people have got to just embrace. It's just technology. It's just using it to help everybody. Yeah.
I think we have one more question, and that's and then you have to talk to Nicola over drinks.
Thanks. I am Nigel Austin from Hawkins Brown, we're architects. It's a very simple one. On those diagonal props that you showed, they're removed.
Yes.
Yeah.
Okay. So what happens is it was just basically because we didn't want to put anything on the floor. We just wanted to get the next floor propped as quickly as possible. And all it meant is you're just putting your load down to the column. You've already got strength there. It's quite. Instead of traditional propping, you aren't sterilising the floor, 2 floors. You're giving it that space, and we all know that it's challenging on site. So, yeah.
Great, thanks.
Thank you. Thank you, Nicola.
Thank you.
Matthew Teague, thank you for agreeing to be our speaker. He is the Senior Architect and Project Manager for Tata Steel. He has an impressive working history with the steel industry that spans over 22 years. As an architect, Matthew's work centres around how they, as manufacturers of steel construction products, can respond to customer requirements in a rapidly changing sector, and how design decisions can optimize outcomes on site during the project's lifetime, including end-of-life reuse and recycling, because steel is good that way, isn't it? Before joining Tata Steel, then Chorus, Matthew was an architect in private practice specialising in housing, and spent some time in London Transport as the design manager for environments. Recently, he's been involved in projects where design for manufacture and assembly, of course DfMA, has been employed, rather than more traditional methods of building, procurement and construction, and continues to work and invest in this field. Matthew and his family live in London. Both children are now at university. They've flown the nest yet? Or they're still staying at home? Oh, wow, bless you, good. Matthew builds bicycles outside the working week, also from steel, impressive, and is even occasionally known to ride them. I give you Matthew Teague.
Okay, I don't remember writing that, and I know what you're all thinking. He doesn't look that old. Right hand. So, it's a little bit of a diversion from the title of the talk to begin with, because I thought it would be worth exploring some of the difficulties we have as a steel manufacturer. It's quite nice to be in a room where pretty much everybody in the room uses your product. So we're a bit like, supermarket in terms of you guys. Everybody uses us. We are the largest steel maker in the UK. Most of our steel making operations are based in South Wales, where we have Port Talbot, which is a very large integrated steel works, and we have the capacity to make about 6 million tons of liquid steel a year. It's a little bit less than that now because of the pandemic and what have you. It's more like sort of closer to 4. But we invest very heavily in our local communities. So our contribution to the Welsh economy alone is in the region of 3.5 billion per annum. And we still directly employ about 8,500 people in the UK. We have several manufacturing sites, so apart from making steel, we also make building products. We make building products in North Wales at our Shotton plant, where we make things like steel decking, which you saw some of the steel decking on the forge just now, which was repurposed as a beam. We make composite panels, and we also make painted steel, so we make pre-coated steels of various types. We make steel for packaging in Trocester, also in Wales. We make metallic coated strip. And then over towards the east side of the country, I think Corby is a little bit further east than it's shown on the map, we make tubes. So we make tubes for construction, and up in Hartlepool we make tubes and pipes for construction and the oil and gas industry. So we're sort of very heavily invested in the UK. However, I mean, steel has a problem, and it's the elephant in the room really, is that steel is a very carbon intensive industry. So for every ton of steel we produce in the region of 2 tons of CO2. And that's despite being one of the more efficient steel producers in the world. We make steel via the primary process, which is blast furnace and then basic oxygen. And we're of the view that that will continue for some time, because steel will always be needed. The amount of scrap in the world does not satisfy the demand for new steel. So there will always be a demand for new steel. It's how do we make that in a more sustainable way and in a way which doesn't leave us with stranded assets in the future. That's most important. We don't want to invest in the wrong technology in order to move us forward in the carbon debate. So there's a hierarchy of actions, and this is where the DfMA story starts to sort of gain some traction in why we as a manufacturer are interested in. So the first law, if you like, of a circular economy for steel is that we reduce overall. So we reduce carbon. So if you can reduce carbon whilst we make steel, that's fine. But if you can reduce steel in buildings, that's also a very good way of moving forwards. We can reduce the resource. We can reduce the amount of transport that's needed. So things like buying locally or buying steel which has been sourced from less far away, shall we say, is also good. And then there's steel weight. So it's already been mentioned that if you reduce the amount of steel, we reduce the necessity for other things such as large foundations or response, for instance, to overheating. So we can lightweight a building, we can make things generally more efficient. Next on that list is reuse. And as you see, as you go to the right, we have greater emissions and greater resource use in terms of energy to reclaim that piece of steel. One of the things we're very interested in is steel reuse. That's steel reuse directly from the end-of-life building. And we are talking to a number of recycling companies about just how we engage with that market, how we actually make it work without cannibalizing our own markets. It's a very difficult conversation to have with senior management who are sort of saying, well, why would we do that? And the obvious answer is, well, we would do it because we're good guys. Then we have remanufacturing, which is where we take a piece of steel and we do something to it. So we might turn it into some piece of steel for something else. We might take the end plates off. We might make an assembly out of it. But that involves some work, some remaking or turning it into something else, maybe for another sector. And then last of all, very last on the list is recycle, which is where we take the steel and we put it back into the process somewhere. So we either put it into an electric arc furnace and use electricity to turn it into new steel, or we put it back. We can put scrap steel but directly back into the basic oxygen furnace to make new primary steel. So not a lot of people know that most new steel is actually 20% recycled anyway. So there's always some recycled content in steel. This is our journey towards fully sustainable steel, and it will involve a number of technologies. That's the other thing to note, is that there isn't a magic bullet for this. People are talking a lot about hydrogen, but you need a hydrogen infrastructure to use hydrogen, and there isn't really a hydrogen infrastructure yet. We need to work with other industries. And that's not just from our sector, that's not just metals, that could be from any of the other foundation industries such as glass or paper making or oil and gas or chemicals. And we're always trying to align to the Sustainable Development Goals, the UN targets. We're already members of Responsible Steel, and we are a member of the UK Green Building Council as well. So we are sort of trying to be responsible manufacturers. This is our integrated steel plant at Port Talbot. It's not that green. It does have a beach, though. Iron ore and coke, or coal, which is turned into coke later on in the process, come in by sea at the moment. We then mix them together in the sinter plant to make what goes into the blast furnace. That is then turned into liquid iron. Iron ore is turned into liquid iron, and then the liquid iron is turned into steel in the steel plant by blowing oxygen through it. And that's how we make primary steel. And that primary steel is then turned into coil, which is then sent out to become other things like cars or fridges or buildings. There are two pathways generally to becoming carbon neutral, which are in line with the UK government and Welsh government climate goals. Both can use hydrogen at some point in their future, but at the moment we're looking at smart carbon usage, which is taking carbon and storing it and using it for other processes. You can make hydrogen from some of the carbon processes. You can use it to crack methane, for instance. Or we can directly avoid the carbon by adopting something like an electric arc furnace. The likelihood is that it will be a combination of those technologies in the future.
Can I ask you a quick question?
Of course.
You in your last slide, so you have to use scrap to do carbonless using the
This one. Yes. Arc furnace.
because you're pulling the carbon out of the system.
Yeah, the idea here, that's an important question actually. So the thing with steel made in the electric arc furnace is you need very high quality scrap. So one of the problems with electric arc metal is copper. So if you're getting findings from car reclamation, there'll be wires and all sorts mixed up, and you get copper in the steel. We can't use steel with a heavy copper load for very many grades. Construction steel in the sense of reinforcing bars, yes, but not for primary. Certainly not for automotive either. They won't touch it. So we need very high quality scrap. That's one of the problems, is getting segregated scrap of high enough quality to go into that process. So that's one of the conversations we're having at the moment with the recyclers, is how do we ensure that supply, bearing in mind that these days most of it goes abroad. So we need to sequester that supply of high quality steel, make sure we can use it. So that's one problem. Thank you for the question. Decarbonisation transition, I promise you this is the last slide on decarbonisation. There are a number of routes. So the Southwest Industrial Cluster, which hopefully Sam will recognise, is part of the route where a number of heavy industries can group together, for instance, to use hydrogen economy, hydrogen infrastructure. We can use CO2, we can use bioreactors to turn waste industrial gases into other things, and there's another UKRI funded project down at Port Talbot to do that. We can use best available technologies, and an example of that is this turbine that's been recently installed, which is highly efficient and uses waste gases to make electricity. So we are also our own electricity manufacturer down in Port Talbot. As I've said, we're already members of Responsible Steel. The other thing you've got to do is measure how sustainable we are. At the moment, there's a UN program called Race to Zero, which we are looking to join, but it's very hard to measure our impact. There's no methodology for the steel industry at the moment, but we are developing one, which is called the Net Zero Steel Pathway Methodology. We've got to come up with another name. And last of all, there's zero carbon logistics. We've just come into possession of a hydrogen-powered boat, for instance, for moving iron ore and finished product around. So it's little chips away at the cake, at the carbon cake, if you like. And the story about design for manufacture and assemblies is kind of the same story in construction. In government, we've seen these long-term targets come out, so 33% lower costs, 50% faster delivery, 50% higher productivity, lower emissions by 50% as well. And then the projected UK government spend on construction, which is a fairly old graph, so it's probably changed, but it looks like that. So you see this massive drop-off in traditional to a huge take-up of platforms. And I don't actually agree. I think that volumetric and modular, which is here, I think that will actually be a bigger part of the cake than 10%, but it's just my opinion. All of our products have we've already seen. So the Forge uses conform beams for their horizontal beams, albeit turned upside down and filled with concrete, which was a use that, you know, it's one of those bits of serendipity that you sometimes get in the construction industry where someone comes along and says, I think it was Jamie Johnson came along and said, do you know anyone that makes this? And we go, well, we do, which was great. But we also make, you know, the hollow sections that are around the external frame of the Forge as well. So we're quite heavily invested in the Forge as a company, and we've been to visit many times. It's a very good building. If anyone can make it, not sure if you're still doing visits, but it's worth having a look at. And then we've got projects such as Seismic, of which more later, let's go back to that one, which is, again, a UKRI funded project looking at education buildings around a different route, a different delivery of a different sort of platform. This is a project we did with Neath Port Talbot Borough Council and a group called Specific, which is another government-funded catapult looking at buildings as power stations is their motto. So the upper floor and the roof are both generative in some respects. So the roof generates electricity, the wall generates warm air. The wall is something called a transpired solar collector, which is basically a dark piece of steel with holes of a very specific size drilled in at a very specific pitch, which draws air in from it. So you get a boundary layer of warm air next to the steel, and this transpiration of the warm air travelling up the steel actually pulls it inside, and you get a plenum level of warm air, and you can then use that warm air to drive something else like a heat pump. Or you can actually directly, if in the winter, for instance, you can directly vent it to the building for warm air direct from outside. And the roof uses a flexible product by a company called BIP Vico that make a cadmium indium based photovoltaic cell, which is flexible. So it's a self-adhesive cell that goes onto the roof. So that roof could be any shape within reason. It could be barrel vaulted, and we've done a barrel vaulted one as well. And that generates electricity. It's very good in grey sky, which is extremely good for Wales. And it's about 19% efficient, which is comparable to the silicon chemistry, which is used for most photovoltaics. Seismic, as I mentioned, this is our demonstrator down at the Building Research Establishment in Garston, which is looking at education buildings. And the primary feature of Seismic is a two-stage project. One was to work out how the frames would actually become interoperable, and the other one was to build the demonstrator, so that you've got the corner of the frame there at the top in the middle. And the salient feature about that is it's two volumetric manufacturers, McAvoy and Elliott, who are now called Algeco. With those on their modules, a normally incompatible system is now compatible. So you can use one modular manufacturer in one floor, for instance, and the other on the upper floor, or you can use, God forbid, if someone went bust, you could then switch to another manufacturer with a fully compatible product to a partially built building. On the building on the lower right, we have modules from McAvoy in Northern Ireland on the bottom, and Elliott's, who are based up in Cannock in the West Midlands, on the top, with almost no compatibility issues whatsoever. And then it's clad with various products from our cladding portfolio, just to sort of try a few things out. And then the Forge, very lastly, the Forge. Point of this slide is that normally on a building of this size, we'd be using a lot more Confloor. In fact, we'd be using probably about 30 times more Confloor than that, because it would be the whole floor plate. So the other thing we as manufacturers have got to get used to is saying, okay, that's great. Why don't we use less steel? And it's how do we make the value proposition for that work? And it's to do about carbon. It's to do about, and sort of how we advance in a world which is rapidly changing in construction, to lighter weight, to more efficient buildings, to using platforms. And the last thing I will say is that basically this is all predicated on the idea that a building becomes a warehouse of its own parts. So we've talked about reuse. Well, this is a classic case for reuse, and seismic actually is a classic case for reuse, in that if you want to move the building in the future, there is nothing stopping you from taking this apart and taking it somewhere else. There's nothing stopping you from taking it apart, taking all the corner nodes off and putting them in another new building. Although quite why you'd want to do that if you had a serviceable building that you'd taken away. So I guess the last point is that as steel manufacturers, we are aware of our responsibilities and our obligation to the future, and we're working towards it. But one of the ways we are working towards it is getting more and more engaged in this new way of thinking about construction, which is about kits of parts and using products directly from the manufacturer where possible. Thank you very much for your time.
Last but not least, we have Nick Cobre, CEO of Howick. Nick is the driver in the company's pursuit of innovation. By the way, I wrote this, just so you know. He is the third generation of the Cobres to champion this family-owned business and has been involved in framing technology and industry development since his late teens. After earning his stripes on the shop floor, assembling machines and sweeping the floor, Nick went on to head Howick's UK office for 7 years, laying the groundwork which established the UK Europe as Howick's largest export markets. He has also spent significant time with US-based customers and has taken the lead in a number of collaborative R&D projects, which eventually became customer feedback-led standard features across the industry. Nick has developed a deep understanding of the global construction industry and technology across Howick's global user base, from simple construction projects to high-tech installations. His focus is on driving Howick's team to continue to evolve technologies for better building and advocating for more efficient and sustainable construction practices throughout the industry. And also this event is his brainchild and his idea, and the speakers that we've got and the ideas he's got, like who should be talking about what, that's all Nick, by the way. I give you Nick Cobre.
Thank you, Cindy. Yeah, so as I mentioned early on, was that there is not that much innovation in construction, but there's a lot of innovation in this room, and that's really the challenge we're facing a lot. There's the innovation's there, but it's getting the end clients and everybody else moving forwards in the right direction together. So I wanted to take a bit of time to talk about a new product that we actually tried to launch in the end of 2019, which is the worst time to launch a new product, where we have to be traveling around the world showing people how it works. So we've developed a product which we've called the Extender, which is a telescopic stud system. So the idea behind this was we started off very early on with trying to go into buildings and fit studs to it, and we were working to 0.5 millimeter tolerances. And everybody knows that buildings are not built to 0.5 millimeter tolerances. We're talking to people about inches and sometimes feet. So the first process was to go in and laser scan everything. And that works, but there's a big cost to that. And then you go to design it, and then you show up on site, and someone's screeded the floor, and it doesn't fit. So we sort of stepped back and said, how do we solve this problem? How do we solve the problem of that we're super accurate, but nobody else is, and they don't actually want accuracy, they just want speed, and they want something simple. So I'll skip around a bit because the presentation is quite long and I'm trying to shorten it up. So we developed a system that made of 3 components: a C stud, an R stud, and a U track. So those 3 components fit together in different combinations to allow us to build a panel that we can adjust the size of. And within reason, it can be any size, but in reality, we're limited in the respect of either you've got to have a certain overlap for structure, and then you've also limited by where you put screws and openings and other holes. So we basically came up with 3 common panels. So we had a customer come to us and he wanted a stud that slid. And we said, hang on, let's step back from this. We can make a panel that slides. And then we thought about it, we can make a panel that slides in 2 directions. Hang on, no, we can make a panel that slides in 3 directions. Because the floor's not level, but the roof won't be out of level as much as the floor is in most cases. So this starts. Okay, animation not working. Right, so I'll talk about 3 projects, or 3 types of projects. The first one is wind over construction, and Amir is here from Boston, if anyone wants to talk to him about this particular project. We did a Westfield shopping centre in New Zealand, which was our very first project. And then we've done a couple of projects in Wellington in New Zealand and Rondo in Australia, who's part of the CSR group, have taken on some of our machines and are using them in Australia. And everybody's using them differently, so it hasn't really got to a standard process yet. So this project in Boston was one of the very first ones we did, and it was quite interesting. It's a 100-year-old building, and at the peak of the pandemic, so no one could travel. So the team from Windover went in and laser scanned the building, and that was our starting point. We sent the machine to the Autodesk Technology Centre and installed it remotely over the phone. The guys from Windover did the scanning and all the design work. Then the team from Structsoft in Montreal did the design of the panels. The team at Autodesk's Technology Centre workshop crew actually made the parts on the machine and put them on a truck that then went to the site. So you can just see the machine here. It operates pretty much the same as any of our other standard machines. You can make standard panels, but then you've got these added features that you can make these telescopic panels. So you can see the guys putting them together here. Very simple. The 2 pieces just slide together, which gives us our telescopic, and the screw holes on the side allow us to fix the positions off once it's in place. So doesn't really take much room. It's all done on the floor in this respect, but typically in a factory, you're going to be working on tables. These guys had worked with standard panels, but they'd never worked with anything like this before. So again, a little bit of phone support, some late nights, it worked pretty well. So installation process, again, these guys installing these had never seen these sorts of panels before. And it just sort of shows how easy it was. Again, with the mayor and the team, we discussed how they were going to work, how much compression we could get in them. The key points being we can take it in the lift. So we've done some hospital projects back in New Zealand where the issue is they can't shut the building down. They can't have noise, they can't have dirt, they can't have waste. And those things are just solved by this as kind of a byproduct of what we were trying to achieve. So very typical for the retrofit market. Otherwise, you've got guys with a big bundle of studs, chopping and cutting and hacking, and you're relying on them to get the spacings right. So we can set the spacings within standards. Things like the sills and that, it just makes life easier for the installer. So you've got 2 guys running around this site putting all these panels on. And we take into the site, we don't take anything out. There's nothing to take out. So first project we did was Westfield Shopping Centre, and it was quite a big undertaking. They were 3 months behind on the project when we made the first panels, and they managed to get the project back on track by the end of the job. What they found with that particular project, if I go back to it, they did basically partition walls for the shopping centre. They did soffit panels where they bolted them to the roof and then pulled them down to a laser level. And through the process, something we didn't think about, but 90% of the panels were identical. And then 10% were made to adjust to suit the funny shapes of the building. This project is another one we're doing in New Zealand. It's a 16-storey apartment block. It's a conversion of an old building. There's 11 stories of it, have our framing in them. And we can just see some design of the 3D there. So this project was a mixture of panelised and flat pack. And we made all the panelised panels up in our factory in Auckland and shipped them to Wellington, so equivalent of going from here to Edinburgh. So a bit of remote working. You can see some panels in place here. What the client found is that their installation times were the massive savings. So when we did flat pack, they saved 50% on installation time. When we did panelised, they saved 75% on installation time. And it wasn't just the time on site, it was the number of people reduced too. So they effectively had crews of 2 on each floor, and we were doing 3 or 4 floors at a time. And they came in straight into the site, straight into situ, and they had a little staging area because Wellington, a bit like London, there's no parking. Another project that's come out of this that we're doing at the moment is the Rail Control Centre in Wellington as well for the same client. So existing building, they've designed this great curved structure that they want to put in, so we can not only telescope, but also using some of the stuff that Scott's developed, we can curve it as well. So it's a really flexible product, but that design piece at the start is the key to it, but not so much as it would be if it didn't telescope. So Rondo in Australia, another example. So Rondo took on our machines after their customer who builds the Westfields said, we have to have this. Everything we do from now on is this, or we're going somewhere else. So as a big customer, they said, right, we need some of these. This particular project is flat pack, so all the bits came in as a kit of parts. And this is something we kind of face, which you'll see in this video, is when we start with new building companies, they can't get their head around the concept. So let's go simple. Let's go really right back to simple. We'll make a panel that's 3 meters long. And this one is studs at 600, but we can do the studs whatever we like. And it's made up of studs and new tracks. The studs can compress anywhere from 1.9 meters up to 3.2 meters. And the concept behind this is we're selling you a wall. We're not selling you studs. We're not selling you meters of steel. We're selling you a 3 meter wall that you can snip and cut if you need to make smaller wall. So stage one's this. Stage two is then how do we use this and make doors and window openings and the like. And that's where that kind of 10% piece comes in. The majority of panels are these. And the reason we went 3 meters too is it fits in the back of a van. So the contractor who's doing a shop fit out could have half a dozen of these in his warehouse. He grabs one, he takes it to site and puts it up. And the installation process is literally that quick. So again, Rondo then took it, this is another project they're doing where they're doing all the panels on the roof. So the panels were assembled on the floor, lifted up in the boom lift, and just finalised into place before they did the final fixings. So these things started to grow, and then the next one was double T concrete slab. Now, anyone who's ever worked with those will know that to fire stop them is an absolute nightmare because you have to get the framing to fit inside those gaps. So we made these sections that you see here that are about 2 meters long as a piece, and they're all telescopic in every direction. Again, up on the scissor lift, push it into place, seal it off, and it was a 2.5 minute install versus where they're telling us they're 45 minutes to an hour normally. And then on top of that, which is a little bit hard to see here, but we made a telescopic panel underneath. So we put those to the roof and then we use the telescopic panel to seal to those. So we're doing a lot of these at the moment for the customer because it's just so easy for them. Again, it's a standard kit of parts because those double T's are within reason, within a tolerance, and we know we can cope with that. So that's kind of the telescopic thing that we've done. Some other projects that we've been working on, and you would have seen in Nicola's presentation, the other building we're working on. So one of the things we're getting asked about is coil loading. Coil handling is a major issue for everybody because of health and safety. So the first generation system we made here for loading came from the requirements of customers who don't have cranes, and fork trucks are just dangerous, but that's what most people use. So we started with a system that can load their coils on, and basically it's a human controlled robot to drive it. Automation will come shortly after. The next gen one that we've started to do is, because we do machines with different gauges and different material thicknesses, so, and tipping a coil is also an issue. So the coils will generally arrive, as we call eye to the sky. So we tip it up, we then pick it up with our robot arm, and then place it in the stillages. So this particular unit can hold up to 30 tonne of coil, which would be 2 or 3 days production for most people. So they can come in, load it all on, and then load it into the machine. Or if you've got a machine that does multiple sizes, you can have multiple coils stored and ready to go. So this is something that's in development that we're talking to quite a number of customers about at the moment as to how it fit in their factory, because it has to be modular and because the orientations might be different for different factories, because no two sites are the same. And usually when people are thinking about this, they're 99% through the way of designing their factory or machines are already in place. So that's something we're working on. The big heavy building we were talking about before, so this is the building's actually going up now. They're partway through it. So that's half the building on the truck. So we're doing 2 truckloads for the whole building. This one is 26 meters by 48 meters. It's got a single small column in the middle. It's possibly a bit over-engineered because it's the first one, and we really struggled to get it through the council consent process because we've never seen it. We want you to test it. So that was where all this FEA came in, because we couldn't build a building and test it. So we had to prove to them that, look, we think it's going to work. This is how we're going to work. The team from Brighton Wood did a lot of work on this for us, and then we engaged with the local consulting engineers and said, here, spoon feed it to you. This is the idea. This should work. We're going to build one anyway on a farm and try it. And that led to this building up. Not the best photos, but they were to that point within 2 days of arriving to site. So that's half the building stood. So they're hoping to be a 5-day process to the point where they're cladding it. Now, the beauty of this is we can make them any length, any size. Very little waste, because it's only the cut-offs and punchings from the machine. And again, they all go back to the mill for recycling, which is great. And we control that at that process. We see huge opportunity for this because we started talking about this probably 10 years ago. People wanted to do indoor tennis courts and horse riding arenas. And I thought, how can we do it without hot rolled? The idea with that particular machine is it's small enough it can fit in a 40-foot container, so we could take it to site and you can run a 28-metre beam on site and assemble it with battery tools, and you can use the high-ab on the truck to stand the building. So it's just thinking a little bit outside the square, and it's something that we like to do, and we like to work with clients that want to do that. And we're always a bit far removed from it because we're the machinery designer, and we're good at machinery. We kind of understand buildings, and we've got great ideas of what we think we could do with buildings, but then we have to work with good engineers that can actually sit back and say, okay, it doesn't meet the building code, it's strong enough, now how do we get it across the line with building control? So using that same technology, we started to play around with modules, and we thought, well, how can we build a module without hot rolled them? Because they've all got hot rolled. So this was our little prototype we made, and using our rivet connection technology, we actually rivet the roof panel and the floor panels into the main structure. So it becomes basically a monocoque box with all the bracing and everything all in the one piece. The other unique thing we can do with the rivet is we can actually clad the panels and then rivet the steel to the steel. So the panels are partially clad where they need to be and then finish them. So that's something we're playing with. We've got to find the right client to work with for that. And the problem is the prototype machine's in New Zealand, and it's not really something we can ship somewhere else in the world. So finding a modular client in New Zealand is not easy. The final one I just want to point out is something we get to do quite often is a bit of concept design. So we keep getting people asking us about ventilated battens. And we get 10 customers come in with 10 different designs that all need certification and testing. So what we tried to do is come up with a design of one that we can make multiple different battens out of the same machine with a few variations. So we do a horizontal version and a vertical version, and we do 2 different depths. And we do punched and not punched. The idea with that is if we can get a group of people together that basically want the same product, because there's not enough volume for someone to go and test that by themselves, that we can split the cost of that engineering and that design and all the testing that goes with it, and then basically they can pay 1/10 of it and they get their machine and off they go. And it's something we find in the industry is really hard, is everybody wants to put their stamp on something, and it's a product like this is, while it's important that it's right, it's not important that everybody's got their own different one, because it makes up less than 5% of the building structure. So that's one of the things I really want people to try and think about, but it's quite hard, especially when you're dealing with really big companies. It's ours and we want it, and no one's going to share it. So we like having discussions with lots of people and sharing those sort of ideas and saying, well, you know, yes, it's your idea, you want to do it, but did you know there's 10 other people who've asked us for the exact same thing yesterday? So I won't stand in the way of the drinks and food, so that's my presentation. If you've got any questions, I'm happy to answer them either now or later.
Thank you, Nick, for the presentation. It's really impressive, very interesting. I have a question on the warehouse project you did. In some structural analysis, what tool did you use? It looks like you do this kind of, you do the structural analysis on every single connection detail.
Yeah, so it was. That's why it took a long time. So
okay.
we initially thought it was going to be 2 weeks. I think it was about 10. So
what software was it?
I don't know, do you know, Nicola?
It was a combination between robot and e-tax.
Interesting to know, because we're in the process of developing integrated kind of engineering, so when you design something, put the load, wind load, everything, actually it gives the answer what kind of sort of linkage to your frame system, the density, the breeze and details. So yeah, interesting.
I think the next step from that too, just touching on that design, is that we looked at just the portals, because that's what was required. And we think we can pull a lot of mass out of that building by actually looking at the building as a structure and actually looking at each portal as a bay and looking at how do we brace the bays and then looking at using the cladding as part of that as well. But that's a big next step. And a lot of the councils, especially in Australia and New Zealand, they don't want to know about this whole structure of the building. They just want to know does that bit tick a box.
Just a quick follow-on question. Is there what is the limit you can go to in terms of ease height on sheds?
It really depends on the section. So we can change the section size, we can change the rivet size to go as big as we want. Like we looked at doing those rivets 40 millimeter diameter, and they give us about 120 kilonewton shear on that section. So we could actually go to a 4-inch rivet and probably instead of a 150 deep section, a 300 deep section. We did some initial design up to 50 meter clear spans, which were getting big, but they were still doable. So it really just depends on the engineering and the actual structure and design.
I don't need the microphone. For your load-bearing walls, you can use those telescopic studs.
So normally for load bearing, we wouldn't use them as telescopic, but it's really just a function of the connection. So we're using self-drilling screws through those holes. You could potentially use something like a self-piercing rivet, which is a bit more secure, to put them back to load bearing. And we get asked that quite often about facade systems because they need to carry more load.
That's it.
Yeah. So what's the maximum gauge you can run through?
For the big truss section or for anything, typically we go up to 3.2 millimeter as a max. We prefer to keep it to 2.8 if we can, just to reduce the loads. And we tend to think we'd rather put an extra stud in than go to a heavier gauge because it just becomes harder to manage.
I am from Czech Republic, from Prague. I would like to thank you, Nick, that he has a patient with me, Alexander Bory. You remember, we cooperate with company now, and it is very difficult in Eastern company to present LGSF system like I have possibility to see it, and I very appreciate it that I was invited and I can come back and show what's it going really on GSF systems around the world. Thank you very much.
Thanks.